Hi, I'm Ken Shep from the Laurel School in Shaker Heights, Ohio, and you're watching NASA Now.
When you get to Mars, you use
what that does on the asteroid,
that the astronauts have breathed out.
the gravitational effect of those planets.
Hi, I'm Maria, and welcome to NASA Now. In this episode, we're going to learn more about how engineers use the engineering design process to develop a concept rover that might one day go to Mars. That's ahead, but first, check this out.
What is engineering and why is it important? Engineering combines science and mathematics to solve real-world problems. And engineers? Well, they're people who have scientific training and use that training to design and build products, machines, systems, and structures. Engineering helps us solve problems and improve the world around us. It also lets us improve existing solutions by making them stronger, safer, and more efficient. So the next time you hit a golf ball or use a smartphone, think about how engineering helped make that possible.
An aerospace engineer is just one of many specialized careers at NASA. Here to talk more about what they do is Jennifer Keyes from NASA's Langley Research Center. She'll also tell us about how a cup led to the development of a concept rover that might one day help us explore the surface of Mars.
So an aerospace engineer is someone that deals with flight. Everything from flying in our own atmosphere here on Earth to flying through space and even flying on other planets. We can design new concepts, we can design things that are actually going to be built, and sometimes we're lucky enough to even get to actually build and then fly our designs. Some of the ideas for the projects that we work on come from seeing a problem that really needs to be answered. Other times, what we work on is directed from our colleagues at NASA headquarters. Two of our engineers were watching a replay of one of the Mars landings when the rover came down through the Martian atmosphere in one of these big balloon airbag structures, and it bounced and bounced and bounced. And then the rover would unfurl and the rover would drive off and had these little tiny wheels. And they thought, look at how much more ground it covered when it was bouncing than it did on its small little wheels. So we worked with some of the designers here at Langley and actually came up with wind tunnel models of our various concepts. So this is affectionately known as TumbleCup because it looks like it has all of these cups. Again, so just picture, our coffee cups in here. We were able to hook this to a balance in our wind tunnel and then blow air onto the model and measure how much it would get pushed by the wind. We started working with JPL that had worked on inflatable tumbleweed rovers, and they've actually built several of their models to nearly full scale and have taken them down to Antarctica, tethered them to a spot, and have let them roam by the wind in Antarctica for several weeks on end to see how far they travel and what they can pick up for sensing and temperature and all these different sensors they can put on it. It was a great project overall. Having something that's blown by the wind and can track where it's gone, can sense temperature, can sense even the chemicals that are in the air or the chemicals that are in the soil. All of that can build a better understanding of what a whole region of Mars would look like versus just sending a static package or a small rover that would only be able to explore a small area. In theory, Mars Tumbleweed could traverse a large area and really get us even more information.
What is the engineering design process? Simply put, the engineering design process is a series of steps that help guide engineers to solve problems. The first step is to ask. Clarify the problem. Find out exactly what you're going to create or do, as well as the design or construction limits. For example, you might design a capsule made of plastic that will protect a raw egg on impact from a drop at 10 meters. Step 2. Imagine or brainstorm. You and your team should come up with as many solutions as possible. They can be simple, complex, or even a little crazy. At this point, there are no bad ideas. Step 3. Plan. Select the most promising idea and sketch it out. This helps you visualize the design before you build it. Step 4. Create. Build the model using the plan your team developed. Step 5. Experiment. Test the model your team created. Measure and record your results. Step 6. Improve. Evaluate the model's performance based on the measurements and results you recorded. Ask what worked, what didn't work, what could be improved to work better. Be sure to list any problems and possible solutions. Then try to find ways of improving the model to give better results. Be sure to change only one variable before retesting.
Well, that's it for NASA Now. Visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.